representation. Now we go to the collision rate like this. So how come we have the collision rate here represented by Z2? Okay. How come Z2 is equal to Z1 times n star molecular density times a half? Let's go to the whiteboard. Have a look over here. What is this? This is double counting factor. And this number molecule per volume, and this is collision frequency. How come this must be time or half? So frequency is actually frequency of the collision is the collision that occurring on one molecule. This is that already we count. And now we can count the total frequency of collision just by, that is actually the collision rate between all the molecule of the gas. Just only multiplying Z1 times the molecule density. Okay, now because that the collision happening between the two molecules, so we cannot just count or just multiplying by molecular density, but must be with half, because one collision is counted by half happening on one molecules. So now let's go to calculate where is this number from. Okay, as you know that we just count here, from here we can count, we can again write it here. This means that this times V times N stars or N with V, then time to this. Okay, now should be time again that, because this is actually Z1 time half and stars. From over there we can now calculate that this should be a half time let's say 2 K time V time N per V is or density squared. From here we can write it, that one, I think I can write by this one equal to half, a quarter, sorry, time to this, isn't it? From here. So from this number, you know, meaning we get this, isn't it? So then Z2 is equal to time V time N squared, and this is exactly the same as This is number of, the root of 2 come from. So this is actually the collision rate. Let's go back to our presentation. You have to remember that the value of n stars is actually, have the value the same as n per v is equal to, you can see on the right side, on the right side one on the box, you can see what is the value of that. Let's go back to the whiteboard. From this. So we know already the collision rate, but n here, what is this equal to? We know the ideal case have this and this n just equal to this. Right? We just rearrange the equation, then we get this. And this, is equal to A. So, how come? Because n per n Avogadro, this actually is number of mole. When it is number of mole divided by volume, then it is equal to molarity. So, meaning that n per v over here is equal to A time number of Avogadro. See? So then from there we get this, and n per v equal to p time n per, exactly, so we get this number. So from this one, meaning that n per v this can be replaced by that equation. Let's go back to the presentation. After we count already the collision rate of molecules, now the same molecule, let's say imagine A with A, but in the container we have not only one kind of molecules of gas, maybe we have 2 or more. So now we count the collision rate of different molecules. As I show you, then we have count the rate molecule, the rate of collision of one type of molecules. Now different molecules. I show you in the presentation very clearly. Just have a look over there. Collision rate Z2 for AA as given by that equation. Now if we have the collision between different, let's say AB, collision rate of molecule A and B, just replace dA, the radius of molecule A, by radius of the molecule A and B. So the distance between two centers of molecule A and B, and also V average is V average of A, B, not only A. Just replace it, and we get the equation. Again, remember that N per V is equal to the molarity time Avogadro number, and so on and so on, as we saw you earlier. Now we go to next slide about mean free path. This is the last topic of our meeting today. As I mentioned, I showed you earlier that between the collision on the molecules, then one time the molecule doesn't collide. So the distance that the molecule does not collide, then we counted how long. So mean free path means that the distance, mean distance that the molecule free from collision. And the value of the mean free path as given in the equation by distance traveled per unit time divided by number of molecules it collides within unit time. So meaning that equal to velocity average divided by collision frequency. So we can see it here that mean free path is represented by this equation, and you know exactly that this one is equal to norm and per free. Just put it here, then you get this one. That's why mean free path is equal to this. I think you know that mean free path is independent of temperature. The mean time between collision is temperature dependent. So this is the meeting today. I think finished with the collision of molecules. Next meeting we will go to the chemical kinetics. I hope that you learn by your own or with your friend in other times. Discuss it with your friend. If you don't understand or any queries that you need to ask me, don't hesitate to write me email on Ikhsan@ymail.com. So students that get difficulties on learning the collision of gas molecules, on collision frequency, collision rate, and mean free path, again, just write me on Ikhsan@ymail.com. Thank you very much for your attention, and again we will see it again in the next other topics that is chemical kinetic. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh. Thank you.